Angle relationships and similar triangles. I enjoy watching the Big Bang Show, so here's a funny. Are you a 90-degree angle? 'Cause you looking right. That is very much something that Howard would say. Types of angles. So this should all be review from geometry, so hopefully you will whiz right through this. First of all, we have vertical angles. These are two angles formed by intersecting lines that are always congruent. So over in our example, 2 and 3, those are vertical angles. They're across from each other. You can think of them as they make a V, and they're congruent, which means their angle measures are equal. So I'm going to write down here that angle 2 and angle 3 are vertical angles. That little symbol in front of the 2 and the 3 means an angle. I would like you to now pause your video and write down all possible combinations of vertical angles in this image. You should have 4 different combinations of angles here. Next, we have parallel lines. Not really an angle, but it fell into this category. 2 lines that do not intersect and are coplanar. So they don't intersect, meaning they don't cross each other, and coplanar just means they're on the same piece of paper, for example. They wouldn't be 3D. When a line T intersects those 2 parallel lines, it's called the transversal. So in our picture over here, lines M and N are parallel. The way that we write that is M parallel to N, those little parallel lines. And T is our transversal, because it's the line that intersects both M and N. I don't know of any shorthand way to show transversal, so we just have to write that word out. By the way, you should be copying everything down on your notes that I'm writing on the screen. Next comes corresponding angles. These are 2 angles that have the same position. I like to think of the letter F whenever I'm looking for corresponding angles. So over here I've drawn a purple F in the picture, and it's the angles 4 and 8, the angles that are just, I don't know, nestled into the F, I guess. That's just how I think about it. So I've written angle 4 and angle 8 under corresponding angles. I want you now to go and find the other 3 pairs of corresponding angles. Hopefully you realize that you could draw this F upside down. That's the only way that you would get 2 and 6 and 1 and 5. Next, we have alternate interior angles. These are 2 angles that lie between 2 lines and on opposite sides of the transversal. So it's going to be between M and N, but on opposite sides of T. So one example would be angles 4 and 5. So those are alternate interior. Interior means they're inside of our parallel lines, and alternate means they're on opposite sides of the transversal. So go ahead and pause your video and find the other 3 pairs. I'm sorry, not 3 pairs. There's only one other pair. The one other pair of alternate interior angles. That would be angle 3 and angle 6. Next, we have alternate exterior angles. Same thing, but now we're talking about the exterior of M and N. So we're looking outside of our parallel lines. So if I'm looking outside of them and I'm looking at alternate, it would be, for example, 2 and 7. And then our other example would be angles 1 and 8. Okay, we're going to do some examples where we find the measure of an angle, given some expressions for angles. So for this first one, we need to figure out if these 2 angles, the 10x minus 12 degree and the 5x minus 3 degree, if those are alternate interior, alternate exterior, corresponding, vertical, anything. They're definitely not vertical, and they can't be either alternate interior or exterior because they're on the same side of the transversal. If you think of corresponding, so I drew my little F figure here, it's not those either because they're not in the same, both inside of the F. So we're going to have to think a little bit more about this. Something I do know with corresponding angles is that these 2 angles are congruent, so I can also write 5x minus 3 degrees for that top angle there in my corresponding pair. Now let's look at this a little further. Do you recall what kind of angles these are? This was from our last concept, and they make a straight line here. So they're actually supplementary angles. If I add them together, it will equal 180 degrees. So I can set up this equation and solve for x. Now be careful here. X equals 13 is not my final answer because I don't want to know what x is. What I want is to find the measure of each angle. So I need to plug 13 back in to get my two angle measures. In the end, I get 118 degrees and 62 degrees. All right, pause your video and try this example on the right on your own. Remember, the first thing you need to do is figure out what type of angles those are from our definitions above. Okay, these were alternate exterior. They're outside of our M and N parallel lines, and they're on opposite sides, alternate sides of our transversal. So we know that they're congruent angles, so I set them equal, solved for x, and then plugged them back in. Angle sum of a triangle. The sum of the measures of the angles of any triangle is 180 degrees. In this example, we're going to apply that property. The measure of two angles of a triangle are 48 degrees and 61 degrees. Find the measure of the third angle, x. Okay, one way we can solve this is by setting up an equation. X plus 48 plus 61 degrees, all three of them, equals 180. And we solve for x. Now, another way you might do it is taking 180 and subtracting 48, subtracting 61 to get your x value. Both ways are great. Types of triangles. We're going to classify triangles by both their angles and by their sides. Okay, I'm going to talk through all of this, and I want you to make sure that you pause your video and copy everything down. So first of all, acute triangles. All of your angles are less than 90 degrees. And I have an example here for you. Each of those angles is less than 90. Right angle, we have exactly one angle that is 90 degrees. We denote that by that little box in the left corner of my triangle. And then obtuse triangles. That's where we have one angle that's greater than 90 degrees. Next, we'll classify by sides. Again, I'm going to talk through this, and then I want you to pause your video and copy it all down. Equilateral triangles have all equal side lengths. I'm noting that in my example by these little hash marks. They're called congruent marks, so it's showing you that all three sides are the same length. Isosceles, only two sides have equal length, so in my example I've got two that have one congruent mark, and the third one has two congruent marks. And then we have scalene. This is where no sides have equal length. So here I've got a 1 congruent mark, 2, and 3, showing that they're not all the same. Another thing to note about these triangles is equilateral triangles are also equiangular. So all three of those angles are equal. For isosceles, the base angles, so those two on the bottom, are equal. And scalene has no congruent angles. All three would be different measures. Here we're going to classify each of these angles by their sides. We're going to classify each of these triangles by their sides and their angles. In this first example, I know that all three sides are different measurements, so this is going to be a scalene, and one of the angles in here is 110 degrees, so it's going to be an obtuse triangle. For my next example, I have a right angle, so it's going to be a right triangle, and two of my side lengths, AB and AC, are equal, so it's an isosceles as well. Now I'd like you to pause the video, try this yourself with the bottom three triangles, and then restart to see my answers.